In this session, we will go over the history of reinforcement learning. While today, reinforcement learning algorithms can accomplish impressive tasks like being the world champion at StarCraft, the practice has been around for more than half a century. We'll go over a few of these techniques developed by these pioneers as they still influence the development of modern algorithms. Mainly, we'll look at value iteration, policy iteration, and Q-learning. Before diving into each of these algorithms, let's take a step back and look at a timeline. Hindsight is 20/20, as our intelligences will learn, and the advances in the field of RL will be more obvious given the history surrounding them. Here is a sample of major reinforcement learning algorithms and famous applications through the decades. Arguably, the birth of reinforcement learning goes back all the way to 1957, when Richard Bellman derived the Bellman equation. Although it is a simple equation, it's incredibly powerful and the basis for all the algorithms seen here. Because of this, we'll be focusing on this section of time in blue, which are all techniques without the use of neural networks. In fact, they can be done by hand, although a computer would certainly help speed things up. So before we jump into the math, let's see if we can build up our intuition. These algorithms come from trying to capture how humans and animals learn, so let's practice quantifying our own learning strategies. Time to snuggle up for a story. This is the hero of our story, the gumdrop emoji. It was enjoying a simple winter day playing frisbee when it slipped and fell onto a frozen lake of death, which looks something like this. Looks like a terrible time, doesn't it? We have ourselves a 4x4 grid where we can move left, down, right, and up. Those blue swirlies are holes of death. If the gumdrop enters a cell with one, it will fall into icy cold water and die of hypothermia. To make matters worse, the lake is surrounded by slippery boulders. If the gumdrop moves in the direction of a boulder, it'll end up slipping back into its original position. Luckily, there is a way off the ice. In the bottom right corner, there's a safe ramp to get out, which leads to a nice warm cup of hot cocoa. This is a famous RL problem used as an introduction into the field. It was popularized by OpenAI, which has an API to build this environment if you want to interact with it using Python. So what do you think? What's the quickest path off the ice? There are 3 optimal paths, one of which is shown here. We as humans can find these kinds of paths due to our experience. But how would the gumdrop figure it out? It's just a bunch of bits in an Android phone. It doesn't have our human experience. We'll see how the gumdrop can learn this with value iteration.